Okay, for 483, they give us this system, right? And for A, it says, Candace noticed that each equation contains a 2x minus 1. So she says, can she substitute the 3y for 2x minus 1? So she wants to take this 3y and put it in to replace this. And it says, can she do that? And yes, of course she can do that, because look, this statement says that 2x minus 1 and 3y are equal. So wherever we see a 2x minus 1, we could replace it with a 3y. Wherever we see a 3y, we could replace it with a 2x minus 1. So yes, she can do that. Okay, so now so yes, she can, and because they're equal. Okay, for B, it says substitute 3y for 2x minus 1. So let's do that. So we're going to take this bottom equation, 5 times 2x minus 1 plus y equals 32. And we're going to substitute for this. We're going to put a 3y in there, right? Okay, so let's see what we got. We got 5 times 3y plus y equals 32. 15y plus y equals 32. 16y equals 32. So y equals 2. So we got y. Now we have to solve for x. And we could use any equation. I think that this top equation looks a little simpler, so I'm going to use that one. 2x minus 1 equals 3y. So 2x minus 1 equals 3 times 2, right? Y is 2. 2x minus 1 equals 6. 2x equals, add 1 to both sides, 7. X equals 7 halves. So we get the ordered pair 7 halves, 2.